Then let's go ahead and jump into lesson 7. So if you remember in lesson 6, we were introducing you to data structures. And if you recall, data structures are objects that allow us to contain multiple data values. And so we introduced you two different data structures, but the primary one that we wanted to focus on, in addition to the stack and the queue and the linked list, was the array object. And if you think about it, you know, when you just have a single value that's stored at a variable location, you know, there's not much you can do with that other than write to that location or retrieve the value from that location. But when you have data structures that contain multiple data values, then there's a lot of things that we can do with them, you know, to manipulate the way that that data is organized within that data structure. So sorting would be one of the most common things that we do. We want to sort them maybe alphabetically, numerically. There'd be other sorts that we could apply in there as well. And you might need to take all the values in there and reverse the order that they are, just completely reverse the order. We also do things like splitting values out. So we might grab a few of the values from a data structure and put them into another data structure, or take two data structures that have values in them and combine those together to make a larger data structure. So that's called splicing, or yeah, that would be splicing. Because it's kind of confusing, the terminology, because you got splitting, which is to break it apart, and splicing means to actually combine them back together again. So anyway, the point is, you've got data structures, lots of data in those data structures, and now we're going to look at different ways of manipulating the values in there, specifically in lesson 7, how to go about sorting the values in there. Now, the other thing that I should tell you is that we're going to get into two different types of sorting algorithms in here. So these algorithms are code that I've got actually examples for you, and I'll have you download those. In fact, if you want to get started on that, why don't you do so? You could come down here in lesson 7 and you see this link right underneath of Introduction to Sorting Algorithms. Right there I have a link that says Visual Studio Solution. If you click on that, that'll download a zip file, and inside of that zip file, once you extract out the contents of it, it'll just be a solution, a Visual Studio solution. In fact, why don't I just go ahead and jump in and show you this. So if you click on this link here, you can see I've got it downloaded in my web browser down here, and I'm just going to choose Show in Folder. There's the zip, and then I want to just extract it. And once I extract it, I'll get another folder that is the same name, but it's not going to have that little zip icon on it. So let's go back to the downloads folder and show you the difference. So see how this has the zipper on the icon. So that's the zipped file, and you can see it has the extension .zip on it. Then once we unzip it or extract the contents, you'll get the folder with the same name, but it won't have the zip extension on it. And so if you open that folder up, there's another folder, and then right there is the solution file that when you double click on that, that will open up these two projects here, the bubble sort project and the quick sort project, in your Visual Studio application. So go ahead and do that so that you'll be ready here to go through the demonstration. So while you're doing that, just kind of go through, I'll explain a little bit about where we're headed here in this particular lesson. So again, we're talking about specifically sorting. You know, that's the methodology that we're going to look at here, which is organizing them in a particular order. In this particular case, it'll be numeric order. And we're going to then look at the actual code, the algorithm that is used to perform the steps. And there's two different ways that we're going to demonstrate. We have the bubble sort and we have the quick sort. So we will go through the bubble sort in pretty good detail here. I'll take you through and show you how to set up debugging in Visual Studio, so you can actually watch this whole process occur as we go through the algorithm step by step. Then we'll move on to the quick sort. I don't spend as much time on that one. It's very similar to the bubble sort. It's just a slightly different way of organizing or sorting the data. But the other thing that I need to point out here is that these algorithms that we're showing you are important to be knowledgeable of, be aware of, but in your actual your professional life of creating programs, more than likely you would not necessarily have to write the algorithm from scratch. Most of the modern programming languages today have what we've talked about, how we're using these class libraries, right, that give us a lot of functionality. And so specifically with the case of the array, there is in most modern languages an array class that can be instantiated as an object. And once we use that, once we create the object, we have all those different methods and properties that come along with it. And sort is usually one of the methods that comes with the array object. And so we'll show you at the very bottom here that it's much simpler these days to go ahead and sort the values in your algorithm or in your data structure, the array structure specifically, than having to go through all this work here. But the reason we're exposing you to it is that there might be a call for you to have to write a sorting algorithm from the ground up. So it's good to understand the basic concepts that are happening behind the scenes here that make that process work. And it's really not that difficult. So just to introduce you to the subject matter then, sorting algorithms such as bubble sort, quick sort, arrange items in a list in particular order. And again, understanding these sorting algorithms can help you to understand, analyze, and compare different methods of problem solving. So sorting algorithms are algorithms that will arrange the items in a list in a certain order. So, a list is also a type of a collection. And a lot of times we actually will use that term generically. List just means we're referring to a collection of data values, not maybe specifically to a list object or a list data structure. So the example we give here, we can use a sorting algorithm to sort a list of students in ascending order by their last name. In the early days of data processing, sorting was an important problem that attracted a lot of research. These days, as I said, you can find basic sorting capabilities already built into most of the libraries or the data structures that come in those libraries. So in our .NET library, as I'll show you at the bottom of this lesson, it's real easy to use the array object, call it sort method, apply that to your array, and you're done with it. You don't have to write out the complex algorithm that we're going to show you here in just a little bit. But as I said, it is important for you to understand the problem solving aspects of the algorithm and kind of how to analyze an algorithm too. I mean, you need to start looking at code and having a good understanding of what's going on and even kind of the techniques that are commonly used in algorithms for solving certain logic problems. So as we go through especially the bubble sort here, I'm going to take you into great detail and make sure you understand how that one works. Let's take a look first at what the bubble sort algorithm is and the basics of how it works. And then I'll go ahead and pull up my Visual Studio and we'll take it through in a debug mode, and we'll show you how to set up the debug mode, and then also how we can look at the values as we go through each line of code. So the first thing with regards to the bubble sort algorithm is that it uses a series of what they call comparisons and swap operations. So as you'll see as we go through here, we're going to compare two values, identify which is the lesser value, and then if the value on the left is a greater value, then we'll perform a swap operation to correct that, to rearrange those values. So bubble sort works by comparing two elements to check whether they are out of order or not. So if they are, it'll do the swap. Then the algorithm continues to do this until the entire list is in the desired order. And that you'll see we'll set up a Boolean value for swap. And so we'll initially set it up to be false, but anytime we go through the loop that we're going to create here to go through all the data values, anytime a swap occurs, you'll see that we'll switch that, make that a true value. And as long as swap is true, then the algorithm continues to run, because if there is a swap operation, then the algorithm doesn't really know if everything's sorted in order correctly yet or not. It's not until it gets to a point where there are no more swaps occurring, then the algorithm knows that everything should be in proper order at that point in time. So let's take a look at the data that we have here. We have the values of 20, 30, 10, and 40. And the way that they're currently organized is in that order. So the bubble sort algorithm is going to attempt to solve the problem of going through in one or more passes of all the data. And with each pass, it's completely scanning the list of the items. And if the algorithm encounters any out of order elements, it will swap them, which means it'll turn on the true value for the swap identifier. And then the algorithm continues to run while its swap is true. And it'll go through the entire list each time until swap evaluates defaults. And that's when it completes the operation, and it knows to stop the operation. So we'll look at it visually here on the screen, and then we'll go to the Visual Studio and take a look at it. So you can see here in step 1, we have those original values of 20, 30, 10, and 40. So the algorithm's comparing the first two elements, the 20 and the 30, and those are in correct order, so no swap is going to occur at that point. So then at the next step, now it's going to take the next value over, the 30, and then compare it to the value to the right of that, which is the 10. So here now, the algorithm determines that those two need to be swapped because they are out of order. So it does swap them, and as I said, now it's turning on that swap flag, identifying into the algorithm that, hey, we've created a swap here. So as long as that remains true, it'll continue to cycle through the numbers. So we get down here in the third step. Now it's comparing the third value here to the value to the right of it, and those are in order, so no swap is needed. But swap flag is still set to true, so the algorithm has completed going through the list 3 times, meaning evaluating all the pairs, but swap is true, so now the algorithm knows it has to go back through that entire list again and continue comparing the values. So now we're down here at the next run through the array of values. The order now is what we had here in step 3, so 20, 10, 30, and 40. So the first thing to do is to identify those first two values that we have there, the 20 and the 10. And of course, 20 is going to be greater than 10. So a swap does occur. So again, that swap flag is set to true. Then it compares the next two values, which is the 20 to the 30. There's no swap necessary there. And then compares the last two values, the 30 and the 40, no swap there. But we did swap in the first step, so the algorithm still needs to be running. So here we go through another pass. And now we're looking at the values from step 3 up here in step 1 right here. And so we've got 10 compared to 20, no swap occurs. Then we go to the next two values, 20 and 30, no swap occurs. The next pair, 30 and 40, no swap occurs. So now the swap is set to false, so the algorithm knows it can end at that point. Because that, as you can see visually, that is the case is that they are all sorted in order. So here is the actual code that I'm going to pull up for you in the Visual Studio. And down here, this is what we're going to take a look at in Visual Studio is the actual values as we go through the algorithm. So let me pull up Visual Studio here. And open up my program for the bubble sort. Okay, so this is the code there that's written out, and then also the code that you downloaded using that zip file. All right, so we're just in the process now going through to show you how this works. So we have the main method. That's always, every C# program has to have a main method. That's what the compiler sets to be the first bit of code that's going to run when we run the program. We haven't introduced you yet to creating your own custom methods. Now we have introduced you to methods. You use the write line method, right, with the console object. So that was a method that was built into the console object. We just pass a string value into that right line method, and that's what gets displayed on the screen. So in lesson 10, we'll get into how you create your own custom methods. But for now, just realize that a method is just simply a grouping of code that we will want to reuse over and over again in a program. And the way that it works is you create the definition of the method. So that's the definition that you see right here. And the way that it starts out is we identify the value that the method is going to return back to us. And so in this case here, it's going to be an array of integers that gets returned back to us. And then we name it. In this case, we're calling it bubble sort. And then in the parentheses to the right, we're just identifying the fact that it can have values passed to it. So the idea of methods a lot of times is that we take values in through these parentheses, we process the values internally within the method, and then we have a return after we complete our operations internally here. We return the results back to the caller, which is up here in the main method. So that's how we get down here to begin with, is the main method. It builds its array called numbers, puts that into memory, and then the very next line here, it says, okay, now that you have that numbers array, go ahead and call our custom method bubble sort and pass to it that array of numbers that we just initialized up here. So that's all we're doing at this point, is just creating a new array, initializing it with 4 values, and then taking that array and handing it off to our custom method. And so it's down here where all the work's actually being done. Once the method completes, it returns back to the location where it was called. So that's the beauty of a method, is that you've got this custom block of code that you want to have run, but it doesn't disrupt the order that we follow up here in the main. See, we're able to call the method, go out and have it do its work down here, and then return the value back to this point in the code, and then continue on from right there. And so what happens is the bubble sort method will take this numbers array and it'll perform its sort operation, return the results of that sort operation back to this line in the code, and then have this for loop run where we just simply output each individual value of the array so that we can see the results of the sorting that has occurred. So that's the basic functionality of the program. Create the array, pass the array to a method that's going to manipulate it or sort it in this case, and then just display the final results of the array, what it looks like at the end. The actual work that's going on, that's what we're going to analyze, is down here in this bubble sort method. So if you recall back to the lesson and the 3 steps that we went through there, each time that the comparison was occurring, the left value to the right value, so take the first 2 values, we compared to 20 to 30. So there's always 2 values being brought into the method. Well, I should say it's actually the entire array that's brought in, but if you look at right here, this is where the actual comparison is occurring. So I guess I'm jumping ahead a little bit too far here. Let me just point out, we got, again, the method is called bubble sort, and it's just receiving the array up here that we created. Before we actually get into this do while loop right here, we do set a new variable internal to the method. So it only exists internally in this method here, and we're calling it swapped. And you can see we're declaring it as a, as a Boolean type. So that means that it can only accept true or false. 0 or 1 is the actual numeric way that it's stored, but it's treated as 0 as false value and 1 is a true value. And the reason we're doing that is because that's going to be that flag I was talking about that the algorithm is going to use here to determine whether it needs to keep going through this loop or not. Because you can see down here, here's why or when this do while loop will continue. And I know we also haven't got into looping yet, but just realize that this is just a way to continually do the same operation over and over again based on a set of conditions. In our particular case, the set of conditions initially is do all of this work inside of this do section, while our swapped value is set to true. So the interesting thing about a do while loop is it will always do this block of code at least one time, then it evaluates with the while statement whether it should continue or not. So we've declared this Boolean, it's called swap. We're going to use it internally here in the do while loop. Then we identify that we want to have a do while loop, telling the compiler essentially go ahead and run this block of code at least one time, and then once you've completed that block of code, evaluate the value it swapped at that time. And if it's true, which would indicate that a swap occurred internally up here, if it's true, then continue to run that do while loop. So there will be a point, because we're always, as each time we go through the loop, you can see that we're actually setting the value of swap to false. So it only gets set to true if internally on this for loop here, there is a swap that occurs. See right here, if the swap occurs, that's where we set it to true. So if a swap occurs and it's true, the do while loop continues to run. If we go through here and the swap never occurs, then swap would remain false because that's what it's set as right here. So then now when it does the evaluation of this expression, swap will be false, so that will end the do loop. And so that's essentially how the algorithm works. It just continues to go through the loop here until there's no more swapping necessary, which would indicate that all the numbers are in order at that point in time. So then the final task of this method is take the results then, after all that swapping is occurring in our array, take that array that we passed in here to the method, and now whatever it currently looks like, whatever the order is of those values in that array now, pass that back up here to the caller, and then we move to the next block of code after that call of the method, and all this is doing is just displaying the actual contents of the array one by one in the order they are in the array. So this is, hopefully that helps you to kind of understand how the code's going to work here. Let's go ahead and show you how to set up debugging in Visual Studio. It's really a quite simple process. When you're looking at your code here and then you have your line numbers out to the left of it, you'll notice there's a gray bar to the left of the line numbers. So the idea of debugging, the way that it works is that we put in what's called a break into our code using this gray bar here. So I'm going to go down to line 21 out to the left, and that gray bar, I just gave it a click. It's kind of an on-off switch there, you can see. If I click once, it turns on, click on it again, it turns off. So that's the break point. When you see that red dot right there, that becomes the break point in our program. And what that means is then when we go ahead and we run this in debug mode, the program will actually stop running right there at the break point. And once we get to that point, then you'll see that down below here, right now where we're seeing output, we'll actually see another box pop up here called our locals. And what that's going to show us is the actual values of all the different variables that are operating within our program. And so that's how we can kind of track then and see step by step how this program is actually functioning. So go ahead and put that break out to the left of line 21. Now, in the past, I've had you running your program using the control function key 5 method. Let's just go up and show you. That's what you're doing is you're invoking here from the debug menu. With the control F5, you can see that that's actually starting your program without debugging. So at this point in time, we actually want to do just function key 5, or in other words, start it in the debugging mode. So that's what I clicked on there. You can just do function key 5 from your keyboard if you'd like. Do make sure, I think it should be the default in there, but make sure that bubble sort is bolded, because remember that's how we can visually tell that that's our startup program, because I do have 2 projects in here. And so you want to make sure the bubble sort project is the one that's the set as the startup project. Now you can't see it on your screen. I'll bring it over here. You can see it now. I do have the console open, nothing displayed yet because we've halted here. In fact, notice when you look at your Visual Studio, that red circle now has a little arrow on it to indicate hey, here's where we are in the processing of your code at this point in time. And at this point in time, all of this stuff up here, this has all just been put into memory. In fact, this entire function is in memory too, but we haven't started running each line of this function yet. So we're not seeing any output on our console. So it has just stopped at that point, waiting for us to now go ahead and look at it one by one. Look at each of the values. In fact, if you come down to the bottom underneath your code, now you can see that locals window I was telling you about. You'll see that it does represent the fact that we have created this numbers array, and it's showing that it's an array of 4 elements of integer type. And if you click on that little arrow to the left of numbers, you can actually see the contents. There's each of the 4 elements in the array. And then over here are the values that are stored in each one of those 4 elements. So really, at this point, when you look at our main method, we've only gotten this far in the code. So as soon as it called bubble sort, then it hit our breakpoint down here. So it has initialized our array called numbers with those 4 values. We can see that that's all showing up in our locals. And then also the swapped variable is set to false, and we actually haven't even declared, well, we did declare it here, but it really didn't pick that up yet. So it's kind of interesting that it sees that, and I guess the reason it sees that because it did load this function into memory. It just hasn't actually run through all of the code yet. The main thing we're going to focus, well, we'll focus on false too, on swap too, because we want to see it go to true and remain true while we go through the while loop, the do while loop. But we also want to focus on each element here in the array to see the actual numbers changing. So where we are at this point in time is just, getting ready to run the bubble sort method. Now, if you look up at your toolbar, you will see that you have a stop button up there. So if you just want to stop running the program altogether, you would click on that. If you want to restart it, you could do the next icon there, that little restart icon. Then you have the show next statement icon, which is the right-facing arrow. But the one that we need to use here is the step into, because we want to go into the bubble sort function and have it run line by line. And you'll notice the shortcut on that, if you want to use it, is function key 11. So I'm just going to click on that one time. And notice now we've moved that arrow from our breakpoint past the declaration of swapped and into the beginning of our do loop. If you look at the local values below, nothing's really changed at this point. Now I'll go back up the toolbar. I'm going to hit that same button again, step into. Now we are at the swapped variable, and it's assigning the value false to it. Click step into again. Now you can see we're into the for loop. So a for loop, just like a do while loop, is a type of looping structure that allows us to repeat certain steps over and over again within our program. And the way that a for loop works is you set up 3 different values in this set of parentheses here. And don't worry about too much about the details. You're not going to have to write these out yet, but you need to be aware of it, because we're going to focus on looping here when we get to our control structure section. So a for loop, you define 3 values. You first of all have what we call this counter variable. And so we're just creating an integer named I and setting it to 0. And then we'll use I as our, our counter here. As we go through this loop, we don't want to exceed the number of elements that we have in the array. Otherwise, our program would throw an error, because that's what we're evaluating down below here is going to be each of the individual elements within the array. So when you're looping through an array, generally, this, what we'd call the termination statement, that's what the second value is. This is identifying when this loop should terminate. Just like with the do while, the while indicates when the loop should terminate. So we actually have 2 loops going on here, the do while and then internally the for. So in the for loop, we've established the I. We said we want to end it when I is less than numbers length. So length is a property that we can use on arrays, and that tells us how many elements are in the arrays. Problem is, if you look at the number of elements in there, we have 4 elements, correct? I think everybody would agree with that. The arrays, you might recall, are 0 based as far as their indexes are concerned, meaning that this value right here is at element 0. In fact, we can see that down here, can't we, in our locals? See, the number 20 is stored in the array numbers at element 0. 30 is stored in the numbers array at element 1. So the problem we have here now, if we just said run this as long as I is less than the number's length, or you could have, let's put it in here like this, like equals number's length, that's going to throw a problem because the length actually would be 1, 2, 3, 4 elements, but the last numbered element is actually the number 3. So this is typical in a for loop. When you're evaluating each individual element in an array, that terminal value should always be your counter less than your array name and whatever its length is. In this particular example, we had to go one step further because we're comparing. So like when we target element number 2 here, the value of 10, we want to compare it to the element on the right here and its value. And so if we were, once we get to the end, a better way to explain it is what happens when we get to the last value here? We can't go. There is no more element on the right to compare it to. So we actually kind of short-circuited the array. We subtracted 1 from its length as well so that it never goes higher than the number 2 element there, and then compares it to the number 3 element. But it'll never say, okay, number 3 element's the starting point, and then evaluate that with the number 4 element, because that would crash our program. If you tell the program to evaluate an element in an array that doesn't exist, that will crash your program. So that's the thing we need to be careful with when we're setting up these for loops, make sure that we haven't set up a condition here that's going to exceed the number of elements in the for loop. And this one's a little trickier just because we're grabbing 2 values actually each time we go through. So we had to add the -1 here. Without that -1, this would be very commonly what we do for a for loop, just I less than the length of whatever the array is. But for this example, we also have to add the -1. So that's the terminal value, when to stop the loop. And then this here is what we call the increment value. And that's just basically every time we go through the loop, adding a value of 1 to the current value of I. So I is 0 as it goes through the first time, and then once we complete the loop, we go back again. Now I will be 1, go through, and then go back again. Now I is equal to 2, until we hit that terminal value of 3 here, which is going to be our length is 4 minus 1. Now in that for loop, what we're doing is the evaluation to see if the number on the left is greater than, that's this symbol that we see right here. So right here, this is the lesser than symbol. This one here is the greater than. So this is an if statement. Now we're evaluating the 2 different locations in the array depending on what the current value of I is. So just starting at the beginning, when numbers is I, we're saying take the 20 and compare it to the numbers of I, which is 0 plus 1, so that means the first element. So compare 20 to 30 is what we're doing here, and we want to see if the value on the left, the 20, is greater than the value on the right, the 30. If it is, and the way that an if statement works, if that expression evaluates to true, then it will run these steps right here, these statements. But if the value on the left is not greater than the value on the right, it'll skip all of that code. It'll just jump down here to the while loop and see if swapped is set to true. So as we go through here, this for loop will run 1, 2, 3 times each time through. And if there's any swap that occurs at all, then swap at this point would be set to true, which means that then the loop continues until we reorganize the values in the array, and there is no more swapping that needs to be, needs to occur to make it in proper order. Then swap will evaluate the faults, and so then we're done running this loop, and then we're also done running the do while loop. So all we're going to do is just return then the sorted value of the numbers back up here to the caller, and then using the for loop, display the output, the current output of the array. So right now, when we're at the for loop, what we're going to see down here in our locals is it's just going to show these new variables, right? We have to set up I and assign a value to it. So that's what it's showing us down here. So let me step into that now. So now we're going down into the for loop. So you can see that swapped, because we just read this line right here, is set to false. Now we're in the for loop with the I set to 0. And we're going to go ahead and jump down into the if statement here. So I'm going to step into it. There's the beginning, step again. Now I'm at the if, so now it's doing the evaluation. It's looking at element 0, comparing it to element 1, seeing which, if the value on the left is greater than the value on the right. It is not, so when we click step into, notice it skipped the whole block of if statements, the statements inside of the if there, right? It jumped all the way down to here because no swap occurred. Okay, so we'll step into it again. So now it's going to go ahead and run our for loop again, right? Because we're continually running through the for loop for until we get to this terminal value here. So now we're comparing the 30 to the 10. Now the 30 is greater than the 10. So when we get down here to the if statement, that should evaluate to true. So now you should see it goes internally inside of the if. Now what it's doing is it's going to perform the swap operation. So we're looking at 30 and 10. It's going to take the value of 10, which is the right value, and it's going to assign it into this location, or actually into this variable, I should say, numbers. All right, look at the wrong one, temp. So that's a temporary holding place now for the value on the right. Then the next line of code is going to take the element that is the right, where the 10 exists, and replace it with the value of 30, because that's what numbers I represents right now, is we're at that number 1 element, because that's what I's value is, right? If you look down here, there's I, it's 1. So that means we're looking at this value right here that we're going to grab it, and we're going to put it into I plus 1, meaning we want to put it into the element right there. So 10 is in the temp variable, and we're moving 30 now over into 10 slot with this line of code right here. Then the next thing is to take what's in temp, which is our 10, and assign that back into this slot, the number 1 slot or 1 element there in the array. And of course, we just performed a swap operation. So now we want to go ahead and change the variable swap to have a value of true, so that once we exit our for loop, that it will continue the while loop. Meaning basically it forces it to go back into the for loop another time, and just keeps doing that again until there's no swap operation being performed. So now when I step into the for loop, we've compared 30 to 10 and done the swap there. So now you have 30 is the value in position number 0, 1, 2. So array element number 2 is now 30, and array element number 3 is 40. So we're going back to the loop and comparing those two in this example, and they will, when we do that if statement, the 30 is not going to be greater than the 40 to the right of it, so it'll skip the if statement, and that should, at that point, take it back through the for loop one more time, and then it hits down here to the while, and the while is still true now at this point. I mean, the swap is still true at this point, right? So we're going to go back into the for loop. It's actually just going to change swap back to be false, go through the for loop to see if there's any swapping that occurs. If so, set that swapped variable to true, and if it's true, we just keep doing this process. So let me go ahead and step in. All of our values are, if you look at them here in the array, are all properly sorted this time. So now when we go through, we really shouldn't see any swapping occurring. So we just need to go through each of the 3 pairs. And then right there now, it's evaluating the swapped. which was still true there. I missed there was one swap that occurred. Now it's reset to false. This should be the last time through. So just going through each of the pairs, comparing them. There should be no swap. Then we get down here on this one there. So now it's evaluating swapped again. This time swapped is false. So that should end then the do while loop. So at this point now it's going to return the numbers back to the caller up top there. And now we're going to run that for loop, and using that for loop, it's going to go through and just display each of the 4 values that are in numbers in the order that they're, they are stored in the array. And then we just finish it, and here I'll pull over my console, and there you can see we've got the sorted order. Any questions about that? Is that cool or not?
Pretty cool.
Pretty neat.
Interesting.
Yeah, and the reason the appreciation I want you to give to it there is just, how clever it is to be able to very simply go through and compare 2 values, and then just using what we normally would call a flag, in this case called swapped. The flag is what's indicating to the program, whether or not a swap has occurred. And if you think about it, it's all kind of based on the rules that we looked at when we were looking at the lesson and going through, here's how a bubble sort works. The code is actually written to that requirement. And the big operation, of course, is the actual swapping of the numbers in here, which you will be asked to do again when you get into a later class. It won't be quite this involved, but in your first level programming classes, usually you'll be introduced to that concept again of being able to switch values from one location in an array to a different location. Okay, so I think right now would be a good time to take our first break of the morning. So let's go ahead and add 10 minutes to your timepiece and come on back. Okay, we're back. So we just finished up with the bubble sort. I'm going to take you through in the lesson the quick sort here. And I do have an example for you of the quick sort in that solution also that you have open there in Visual Studio. It's quite a bit more complex, though, to actually follow this through the process step by step. I'm showing you how to set up the breakpoint, and if you'd like to go through the quick sort using that technique, you're welcome to do so, but I just won't use that here to demonstrate it because I find that, excuse me, I end up putting students to sleep more than anything when we talk about quick sort because it's a much more involved process. So that's why I demonstrate the bubble sort, just because it's a lot easier to understand. You can see it a lot easier visually using the debugging method. So quick sort, when you compare these two, bubble sort to quick sort, the bubble sort takes a little bit longer than does the quick sort, but the quick sort actually ends up using a little bit more memory. Because the way that the quick sort works is that it actually will take the original values in the array and set up a partition, they call it, and then, which means basically dividing up the group of numbers within the array into 2 different groupings. That's the partitioning of it. And then within the individual partition, it does the comparison to see if the value on the left is greater than the value on the right, and then does the swap if necessary. So when you look at the data that we see in the graphic here, this is the original array in the order that the values are stored in there. So 50, 10, 30, 20, and 40. And so the first thing that happens then is the algorithm will establish what's called the pivot element. That's where the partitioning occurs then. So in this case here, they've chosen the value of 30, which means that we're partitioning the first 2 numbers to the left and then the second or the last 2 numbers to the right there. So those are the partitions at this point. So once we have it partitioned, then it's going to go through and do the comparison. So the first thing it looks at is the 10 and the 20. So obviously those are in proper order. Then it'll go look at the 50 and the 40. those are also, well, actually, we should go back to step 2 here again. I didn't really point out what was going on completely. So when it did the partition at 30, it took all the values that were lesser than 30 and moved them to the right. And so that's why the 50 ended up over here in the right-hand partition. So 10 and then also 20 was on the right of the 30, and so it moved it to the left. So anything that was less than 30 gets moved to the left. Anything that's greater than 30 gets moved to the right in that second step. Once we have that step, then it goes through and, like I said, compares those values for if we're out of order or not. So in the case here, we had the 20 and the 10. It did switch those. And here we had the 50 and the 40. It did swap those out. So then we get down to this step here where you basically don't have any need for the partitioning anymore. They're already in order. So that's, again, you know, it did happen a lot quicker, but it actually is taking up more memory because it's creating 2 additional lists here to have the values moved around that are, you know, those that are greater than 30 move to the right and those that are less than 30 move to the left there. So there's actually 2 methods that occur in this particular program. The first one, probably easier if I just bring my Visual Studio over here. So here is the main method. You can see that it's going to call the quick sort method, which is the method down here. So this is the bulk of the sorting operations. You can see we're doing the comparison here to the right value and the left value, see if the right's greater than the value on the left. And then eventually, as it goes through the, remember how the ifs work again. If this is true, then all these steps will occur, which is where they're doing the actual swapping. And then back here, returning the entire set of the array back to the caller. But within here, right there, you can see it's calling another method, which is the partition method. And that's this method right here. So the partition method is actually the one that's determining where the pivot point is going to be within the array, and then it does all the copying to make sure that everything greater than our pivot point is to the right, and everything lesser than our pivot point is to the left. And then here it's just a comparison and the swapping once it evaluates those values on the left and the right. So it's kind of easy to see conceptually, but like I say, going through and watching it and following it through the debug can be kind of challenging. So we don't actually do that anymore. You're welcome to do it on your own. You do have the code to do that with. But the main thing here is just really knowing that the quick sort is faster, why it's called quick sort, faster than the bubble sort, but you are using more memory because of that partitioning technique. Now, underneath of the quick sort, and I don't have this one currently as a project in Visual Studio for you, but we can go ahead and set this up quite quickly. This is just showing you is what I mentioned at the very beginning of our lecture here this morning, which is that all of the objects that come with the modern day languages will more than likely have a sort method that has already been written. So the way that the array in C# works is array is an object. It's part of the .NET library. And so when we want to sort our arrays that we create within our programs, you can see that here we're establishing a new array. We're basically just setting up an empty array, right? It's going to be of string type, going to be 10 elements in there. And then we just got a while loop right here. That's just as long as we're less than 10, it'll take input from the user. So the idea is let the user randomly input numbers into our program, which will be stored, you know, in each element of the array. Once we get that array built, then right here, we're going to use the C#'s array object, and specifically its sort method, and apply that to our array. So this is the reference to our array that we created initially here and then populated down here. So see, the counter here is going to start at 0. So the first time through this loop, at array element 0, it'll take the user input and put that value in. It'll loop around again, because right here, we're incrementing counter as we go through. So counter returns back to the beginning of the while loop. Now it's a value of 1. So now we're at the 1 element in our array. and we'll assign the user input there. So on and on until we get up to 9 elements, or the number 9, which actually we're starting, 0 base, so it'll be a total of 10 elements. So that builds the array, and then we're passing that array into the C#'s array.sort method. And what that does is takes our array and sorts it in place. So the array that we created and those random values that the user put in there, they're all going to be sorted in numeric order. And so the final output then is just to use a while loop down here, and instead of a for loop, just to output what the final look is, what the final order is of each of those values that were typed in by the user, showing them, how they're actually sorted now in our array. So the while loops were used to take the input, the while loop was used to generate the output, and then right here, that's the key line. That's where we're actually sorting the contents of the array that was generated up here. So let's go ahead and put that into Visual Studio and have you run it. So what I'll do here is I'll just go ahead up to the top of that solution that I gave you. So in my Solution Explorer in Visual Studio, you can see I've highlighted not the bubble sort or not the quick sort project. I've actually highlighted the solution name because I want to add a new project into my solution here. So I highlight the name of the solution, I right click on it, come down to the add option, and then we get a flyout menu, and we want to choose new project from there. And it'll also be a console app.NET Core C#. So I'm just selecting that template type from here, click next. Let's give it a name, array sort, and then go ahead and create it. Okay, so we get our basic template here. Let's go back now to the code in our lesson and just grab all this code here. This is just going to be put into our main method. There are no custom methods here. So this will all run in main. So I just want to replace my console right line hello world there with the code that I just copied. So everything that we just copied there from the example should be inside of the curly braces for the main method. Once you have that in there, you can go ahead and save the program, the C# program there. Remember that little asterisk will disappear from the tab once we've saved it. Now I do need to make this my startup project, so I'm going back to the Solution Explorer. I'm looking for the project array sort. I'll right click on its name, and then in the menu that pops up there, we choose Set as Startup Project. So it's bolded. That's the one that's going to run down when we do our Control F5. Let's go ahead and do that. Control F5. So it's running. And let me bring my console window into display here. You can see there it's asking for a number. So I'll just randomly put values in here. Okay, so you can see we just randomly entered all these 10 digits, and then the sort program, the array.sort method was applied to our array, and then we demonstrated what the output is after that. And what you'll notice now is that the way that the arrays get sorted is numerically, but it's only using the first digit. That's why we have the number 9 after 78. So that's one of the drawbacks that you have is when you're using numeric values. And well, actually, I should take that back. Now that man, got that frog in my throat this morning. These actually, when we, let me move this out of the way. When we take input right here, we're actually bringing them in as string values. So it's actually looking at only the first character when it does the sort algorithm that's built into the array object right there. If we wanted to fix that, what we would need to do is convert our array data type to integers. So I'm changing the very first declaration of our array up here now, so that it'll be an integer array and not a string array. So the reason I made it a string array initially is just because, and notice how the red squiggly just popped up there under my console read line. The compiler's telling me at this point, says, hey, wait a minute, you want me to take a string value that the user types in and assign it into an int value type in your array? That ain't gonna happen. That will not work. So I set it up so that it just took the, what was the expected input from the user, which is always string. And so that's something you need to have burned into your head there, is that anytime we're taking input from the user, that data type is always string. If we want to use it as a different data type, we, the programmers, need to convert that input into the data type that we're looking for. So what we can do then is, as I said, first of all, identify that we want the array to contain integers instead of strings. But then the other thing we have to do is we have to adjust the input here that's coming in from the user so it's no longer string, so that it can assign integers, the values that the user's typing in, convert them to integers, and then assign those into the array here. So it's not that difficult. We can add in here the convert dot to int 32. So convert is also an object of the .NET library, and it has all kinds of methods then for converting values from one type to another. In this case here, what we're saying is we would convert it to a 32-bit integer type. So this is a method too. So I had to take my console read line method, stick it inside of this conversion method, the toInt32 method. So now when we take in the input from the user, it will still be string at the read line here, but then instantly it's converted to a 32-bit integer, and then it can be legally assigned into one of the elements in our array here. So now let's go ahead and run this. Go ahead and bring up my console. Again, typing in just random values here. Oops, I went too far. I didn't have a stop on there, and so when I put in that last value, if I typed again, it actually ended up closing my console window. So let me just run my program again here. Okay. Should add a sentinel counter there just so I could see visually what number I'm at in the sequence. Okay, so there we go. So now it's treating them like integers, and so you can see that we are numerically in order here. So the 6 this time is properly sorted here, right, and the 68 down here. So if those were string values, you'd see that 6 down here right after the 41.
I was able to put 100 in mine, and it actually put mine at the...
At where?
100 at the very bottom of my
Right, was that would be correct, right? 100 is probably higher than any other value you had in that array, right? So that's the correct sort order.
I was actually surprised because I had, the first time I did it, I had it at the very top.
100 became before, did you have all numbers? Were they all 3-digit numbers?
It was after when we changed. It was before when we changed it.
Because the point is that in the first example, it was sorting string types. And when it sorts string types, it's only looking at the first character.
It was when we were doing string, when it was at the very top.
Well, I have to see that to explain what the, what happened there. But just the way that it works is when we're sorting string data types in an array, it always sorts by just the first digit, the first character. In fact, in the string, I was typing in numbers, but I could type in, text values as well. I could have like a list of names and it would sort, but it's always going to sort by the first character. And so that's problem that arises from that is that when you're trying to do numerical sorts, if the values that you're sorting are string, they will not sort correctly in numerical order. So in order to get your numeric values and to be able to sort in correct order, then we need to convert the input from the user, or at some point anyway, convert the values stored in the array to integer values instead of string values. Does that make sense?
Yep.
So that's what I was trying to demonstrate there anyway. And that's like I was, you know, kind of the point where I started here in our lecture this morning is that's probably what you're going to use most often is that sort method that is provided with whatever language you end up using. But you're always going to have that same issue in all languages. So that's important for you to be aware of that so you know how to correct it. If you're using string values, they will not sort in proper order. If you convert them to integers or any kind of numeric values, you float, double, any type of numeric value, then they will properly sort them. Okay, so that finishes the lecture here for this morning. We're going to move on now and cover the midterm assignment, which again is due tonight. Okay, so here is the midterm requirements. You're going to, inside of your main program, create a 3-element string. And we want to name it, identify it as user properties. So an array type of that's going to hold data types of string, and it's going to be ID'd as user properties. There's going to be 3 spots in there, 3 elements in there eventually. Then you're going to create a read line state, or actually a write line. You want to, when you're creating prompts for your user, those will always be write line statements, right? That's text you want to display to the screen. So we'll first have the prompt for the user that we want them to enter their first name, but then in order to get their first name, then we have to actually use the read line method of the console object. And will that take the value from the user and assign it into the first element of our user properties array. So you hopefully start thinking to yourselves, well, okay, I've got this array user properties. It's got string values. There's 3 elements. If I want to target the first one, let's see, that should be user properties in square brackets. What number? What's the first element in all arrays? What's the number assigned to the first element in all array? Not the actual data value, but what element number is the first element in all arrays?
0.
Yes, very good. Arrays are 0 based, meaning that the first element is always going to be element 0, and then the next one is element 1, and then element 2, et cetera, et cetera. So we got to keep that in mind when we're looking at the instructions here, because that's what we're actually asking you to do as the programmer, is to take your user properties array and assign the input from the user to that first element. Then you'll create another prompt, so console write line, where you're going to ask for the user to enter their phone number. Then again, we'll have a read line statement. This time you're going to assign the user input to the second element in your user properties array. And then a third prompt. This is again a console.writeLine statement. Now you're going to prompt the user to enter their email address. And so then you use a read line statement that'll take their input and assign that to the third element in your user properties array. So you've got an array, has 3 elements, and you've set it up so the user can type in 3 different values, and you have them stored in elements 0, 1, and 2 within your array. So now that you have all that input from the user, we're going to generate some output. So you'll use a console.writeLine statement where you're going to start with the text string value hello. And notice I got a space in there because we're going to follow that up with hello, and then whatever they typed in as their first name wants to follow that. And then we'll add some additional text that reads, well, your phone number is, and again, a space, and then again, the value that they typed in for the second element. And then lastly, we'll have a string value that has the comma after their phone number, space, and your email address is space, and then display the value for the third element in that array. So if I typed in there Bill for first name and 123 for my phone number and ABC for my email address, it should say hello space Bill, comma, your phone number is space 123, comma, space, and your email address is space ABC. That would be the final output. So let's take a look at how we're going to do that. I need to come here and close up my open solution here. So let me move my Visual Studio back into your view. Okay, so we need to obviously create a new project here. It's going to be C# console app .NET Core type. Click next. Then we want to call this one midterm. Midterm assignment is fine too. I'm not really particular about the name. Should have the word midterm in there somewhere, I would assume. And so the project name, solution name are going to be the same. We're only creating one project here, so that's fine. So we'll click create. And so here we are with our new project. So the first step in the instructions then is that we want to go ahead and declare a 3-element string named, or 3-element array, I should say, of string type, and name it user properties. So how do we go about doing that? Any thoughts? Well, to declare our array, we need to first identify the type that's going to be.
Which is a string.
Which is a string. So that's what I type in, string, to indicate the type. And then I follow it up with the square brackets, because what I'm really saying is this new variable is going to contain strings, but it's an array structure that's going to contain strings. So that's really telling a 2 pieces of information. We want to create a new array here, and that new array is going to have strings in it. That's the data type we want to store in there. Then we need to assign a name to it. My array works fine. Actually, I think yeah, I did give you a name, so I'm sorry. So that should be user properties. And just typing it in camel case, lowercase u, capital P. So that is the initial portion here, right? We're saying create an array of string type, call it user properties. But then we have to do the actual assignment of new string array, and then put a 3 inside of there. So the left-hand side of the assignment operator is where we're identifying that it's going to be, we're going to create a new array. It's going to be an array that holds strings. We're going to call it, refer to it as user properties. And then over here now, we're actually initializing, well, we are initializing it because we give it a value here of 3. And if you were to look at that, if you were to debug at this point, you would see that there would be 3 elements in your new array called user properties. And by default, what the compiler does is just assign the 0 as the value for each of those elements. So initially, we don't have anything that we've assigned into it, but the default of the compiler for C# is to put zeros in. If we declare, when we're declaring our array, if we also tell it how many elements we're going to have in there. Does that make sense so far?
Yep.
Yes.
Let's save our work as we go. Control S.
I do have one question.
Yeah, go ahead.
How do you comment this line?
How do I comment? A couple of possibilities here. You can use 2 forward slashes. That's what we call a single line comment. So this creates a 3-element array of strings, or string type. Okay, now as soon as I hit the enter key, now I'm back into coding mode. So that's why it's called a single line comment. You can do a multi-line comment by doing a / and then follow it up with an asterisk. That's the opening character or the sequence. And then the closing is a asterisk /. So just the reverse of the opener. So we begin the comment with a / asterisk, and we close the multi-line comment with the asterisk /. So that means now if I press enter here, it's still a comment. In fact, it adds these little asterisks in there. This is something new they actually just added in 2019. Those don't have to be there. The key is that you have the / asterisk at the beginning and the asterisk / at the end. But as long as it's in green in your Visual Studio, then you're good. You're in comment mode. So if you actually didn't get it quite right and you do something like that, you know, you can see visually, hey, wait a minute, that doesn't look right. That's in green. I know green is comments. So obviously that's not correct. And it is very highly advised that we do, you know, use comments in here. For several reasons. One is that you might
Forget what it's supposed to do.
Yeah, you go back, you know, a month or two later and you go, what the heck was I doing here? And you can't remember, especially as you get older. And it might be that you're not the you're not the programmer that has to update this program. Somebody else may have to update it at some point in time. Either you don't work there anymore or you've handed it off to somebody else on the team. So that, again, you know, is helpful for them to understand, well, why did they do this? So commenting is highly advised. And I'm one of the worst at it. So I appreciate you bringing that up because that is an important concept.
Thank you.
All right, so we've done the first step there. We declared our 3-element string array and we named it user properties. So now the next thing is we want to create a prompt to inform the user what type of information we want them to type in when we add the read line statement here. So all prompts, as I said, you always just use a console.writeLine or write. You know, it depends on whether or not, when you're in the console, whether you want the user as they type it in. If that text should be just to the right of your prompt, then I would just use console write. If I want the prompt and then what the user's typing in to be underneath of it, the line underneath of it, then use writeLine. So it's just a matter of, you know, how you want it to look on your screen as far as the output's concerned. So writeLine gives you a line feed, whereas console.write does not give you the line feed. So I'll just use writeLine here. That'll work fine. So console writeLine, and then in the parentheses and inside of quotes, because it's a string output now that we're generating, we're going to type in there, enter first name, colon, and then I always add a space, a space there if I only use the write method. Because as soon as the user starts typing, it'll be exactly where the cursor left off in the console if you use console.write. With console.writeLine, I really don't need to have that space there because I know it's going to drop down to the cursor will be dropped down to the next line, and that's where the user will actually be typing in their value. And that is a statement. We want to end it with a semicolon. All statements always end with semicolons. True in most languages. I'm trying to think of, I guess Python would be one that's an exception. So this is the prompt the user sees. So the next thing in is we want to go ahead and take input from the user and then using that input, assign it into our array. And since this is the first value that we're getting from the user, we want to store it in the first element in our array.
Which is 0.
Which will be 0, good. So well, keep thinking there for me. What's the name of our array?
User property.
User properties, so that's how we want to reference it, right? By name, user properties. And then we just follow it up with the square bracket and then the index value that we want it to be assigned to. So as you said, that's the 0 index value. So we want to target that element, user properties, it's 0 element. And what we want to assign to it is the results of a console.read line method. And so that'll then take the user input and assign it into our array user properties at the first element position. So that's your first prompt and your first input. Let's now move on to the second prompt and input. So the formatting here is going to be very similar for the next two, right? So console.write line in parentheses and in quotes. Now we're asking them to enter their phone number. And then we'll end the prompt statement with a semi. And now again, we want to take the user input and assign that into our user properties, but now at the second element, which is what number?
1.
Number 1, very good. And that'll just be equal to a, oops, what happened there? A console.read line like so. And then one more prompt and one more input. So the next console write line will be in parentheses and quotes, enter your email address. Again, that's a single statement. We end it with a semi, and now we'll take the user input and we'll add it at what element location?
2.
2, excellent. Okay, so there we have it. We've declared the array, we've identified prompts for each of the inputs we want to take from the user, and we've taken each of the prompts or each of the inputs from the user and assigned them at each of the elements in that array. Then the final thing is we just want to now output that string that starts with hello, and then the first value that's stored there in our array, user's name, and then comma space, the text, your phone number is, and then that value, and then comma space, and then your email address is. Now, there are 3 ways to do this. And I believe up to this point, I've shown you all 3, but we'll go ahead and go through those again. And the main reason I want to show you 3 of them is because you should know how to do all 3 methods. There'll be times when only a concatenate will work for your needs. There might be times when the composite formatting is the only thing that will work for your needs. Or there might be times when string interpolation is the best choice. So those are the 3 different options. So I just want to make sure you're clear on all 3 options, and then also emphasize the fact that in modern programming, I would say 99.9% of your output statements where you're combining text and inputs from the user, that the string interpolation method is the preferred method now. That is the newer method. It's simpler to read. It's actually simpler to build. But I still see, because that only came out recently, a lot of my instructions throughout the tutorials in this class still use either the older method of concatenation or composite formatting. And like I said, you need to be familiar with those, because that may be the only thing that you can use to generate the correct output. But like I say, in most circumstances these days, you'll probably use string interpolation. So let's just do them all for you here. And I would recommend to you as the final result for your midterm that you're going to use the string interpolation. And I'll do that one last. So let's start with the concatenate method. That's the more difficult, older method. So it's console.write line still, that's the output is still the same as far as the object and the method. It's just how we write it out inside of the console write line that's going to change. Okay, so there's a console.writeLine statement, and so inside the parentheses, this is now where I would, if I'm concatenating, put in the word hello space, because I want the space to be there before the next value shows up. And then we use the plus operator, plus operator as the concatenate operator. So we're not doing addition here, right? We're not going to add the character HELLO to some other value. We're combining them as far as the string is concerned. And the next value I want to pull in here is a variable. And so I can't stick the variable, when we're concatenating anyway, we can't stick the variable inside of those quotes because it wouldn't then read the variable properly. So the string values go in the quotes. We use the plus symbol then anytime we want to combine a variable value then into this string. And so in this case here, it's going to be the user properties position 0 that contains their name. And so that's the value that I would want to show right there. Then after that, we'll pick up on the string here. I want to have a comma after their first name. So I'll put the comma right at the beginning of this next string. And I made a mistake here. What's the mistake I made? Anybody pick it up?
You forgot the quote.
I forgot the concatenate operator. Right, we're concatenating. We're combining this now with more string text. So there we go. Open quote, comma, and this is going to be hello, and it's Bill, and then your phone number is, and then a space, and then close that quote, and now let's concatenate to it our user properties at element 1. And then we want to concatenate to that the next bit of string, which will be a comma, space, and then your email address is, and then space, and then quote, and then concatenate, and then again, user properties, and this is going to be the third element. Oops, square bracket. Okay, so that's concatenation then, taking string values, using the concatenate operator to add in their actual values that come from the variable. And you'll know that you do this correctly. Notice how the color code is changing in the IntelliSense here. So anything that's a string value is always in this kind of rusty color. And then if we've typed it out correctly, our variables should always show up in that light blue color. It matches what's up here and here for that matter. So that's visually, that's helpful to, if we see something like that, we know we got a problem there, because what it'll do is just type out that text, user properties, open square bracket 0, close square bracket. That would be the actual text now it's typing to the screen. It wouldn't know, the compiler wouldn't know to go out and grab the value from that location in our array. Okay, so let's save that. Let's go ahead and run it, Control F5. So here's my console. There's the prompt, enter my first name, enter my phone number, and enter my email address. There's the inputs. Now there's the output, properly concatenated. Hello, Bill, comma, your phone number is blah, 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 comma, your email address is blah, blah, blah. And I guess I could have put a period at the end there. If I wanted to add here one more concatenation, we could go like this and then quote, period, quote, just to add the period there at the end. And I wouldn't mark you down if you didn't do that. So that one makes sense to everybody? That's concatenation. Yes. You can do it that way. I don't recommend it. I still think that string interpolation is the way that you want to, what you'll be using most often here for most of your coding. But let's move on to the composite format now. So the way that the composite format works is, instead of inserting your variables using the concatenate operator, you can actually put placeholders into the entire string. So what I'm going to do is I'm going to take out this portion here, because what we're going to do is the whole thing now is going to be a string. So I'm just going to get rid of all of that, and then I'll come back and add. So that makes everything a string, right? All the text is inside of an open quote, close quote. So now what we want to do is put placeholders in the string, and then to the right of the string, I'll add a comma, and that's where I'll list the actual names of the variables. In this case, it'll be our array name and then each of the different elements within the array. So however many placeholders I put inside of my string here, I need to have that many variables out to the right of this comma. So let's put in the placeholders, and then we'll add the variables out to the right. So right in here, the way you put the placeholders in is using curly braces. And the value that I put in the curly brace represents, and actually let's put the user properties in here to the right, just because it'll be easier for me to reference them to you. So here's going to be our first variable value. Our next variable value then is the second element. And then our third element. So again, I'm after the string. I've added a comma here, and then I've listed each of the variables that I want to draw the values from to be placed into these placeholders that I'm going to be adding in here. So the 0 placeholder, just like any array, that's essentially what we have out to the right here now, is an array. And we're telling the compiler, hey, here's 3 values. The first value is going to be at the 0 location, the second value is at the 1 location, and the third value is at the 2 location. So when I put the placeholder 0 here, I'm telling the compiler, go grab this first value here and put it in where that placeholder is. So now I'll move over to where it says your phone number is, and the same thing, but now I want to pull in the number 1 variable, which is this one here. And then finally, our address is, in curly braces, the number 2. So that represents our last value down here. So this is called the composite formatting method, where you write out the whole string, and in the string, you add placeholders using curly braces and then numerically representing which variables to put in there. If I wanted to alter this, if I wanted to say hello and then my phone number would be displayed, I put in element 1 there. So now it would actually grab this value and stick it in here instead of the first value. So these numbers actually correspond then, just like our arrays work, they correspond with these elements that are out to the right past the string. So the 0 value is this one, the 1 value is this second one, and the 2 value is that third one there. So just take these values, replace them with wherever the placeholders are listed. That's composite formatting. And then finally, string interpolation. The key here is to begin, or before really the first quote of the string, we want to add a $sign. Or actually, hold on a second. I guess I should run this for you first. So let me save that. Let me run it, Control F5. Just to show you it's all going to work the same. Okay, so same output as before, just different way of representing that output in code. So now we'll do string interpolation. The key to string interpolation is putting that $sign before your opening quote. And the beauty of this is now you don't have to have placeholders and then have corresponding values or variables out here to the right that represent each of the placeholders. You can now just actually, in those curly braces, just stick the actual variable itself. And that's what really makes this so much easier to write and easier to read. So now I'm just saying hello, and then go grab this value. And then your phone number is, I'll get this one, go get that value. You know, we don't have to link it to these variables out to the right here. We can just now put them right in there when we're using that string interpolation operator. So we put that in, then just get rid of all these commas after the string. So you can see it's just one entire string value. And before the opening quote, we've got the string interpolation operator there. So that says, read this as a string, but whenever you hit a curly brace, just locate that particular variable's value and place it in there for us. So a lot easier to read, a lot easier to write. That's why I think it's the preferred method these days. So let's save that. We'll go ahead and run it, Control F5. So first name, still Bill. Phone number 1234567, and my email. And there you go. Again, same output. You know, the user doesn't know that we've changed that underlying code. But from a programmer standpoint, heck of a lot easier to write, heck of a lot easier to read. Now, as I said, and I haven't actually been grading on this for the midterm, but I just mentioned earlier that I'm terrible at putting comments in here. But if you wanted to go ahead and do comments for each of these, I would recommend it. In fact, how about we do this? I'll give you 10 extra points on your score if you put commenting in for each of your blocks of code here. So what's this? This is prompting user for first name input. And what I find is once I've got a structure started that I'm just going to replace values in, I'll just usually copy it and paste it so I don't have to type it all out again. So I'm just going to put the comments right here before each one I want to comment, and then I'll just go and change it. So this is prompting for the user for phone number input. And you can see too, comments shouldn't be real verbose. You should try and be as succinct as possible, because I don't want to have to read a novel just to figure out what a line of code's doing. So those would be some good examples of comments you can put in there. Well, I just noticed something weird up here. I didn't notice this before. For some reason, it added a using statement that we don't need up there either, which is this security cryptography X509 certificates. I'm not sure how that got in there. You should only have to have the using system because we're using the console object both for read line and write line, and that's we're not even using the array object in here because we're not sorting or anything. So really the console object's the only thing there, and that's available in the system library, so you really shouldn't have any other using directives in there. And apparently there are some copies of this out on the internet, because I've gotten a few in my online class where they've got all kinds of weird code in there. And it's interesting when they copy from the internet how they all post the same errors in the same coding. Do your own work and you'll be much better off for it. It'll make you learn and you'll be able to retain it much better down the road. Any questions about the midterm assignment?
No.
So remember that the process here then is once we write out our code, the next step is we want to go ahead and make a copy of all of it. So I'm just selecting everything there, Control C to copy it. Now go ahead and open up the Highlight Me program. So highlight.me. I'm going to go ahead and paste my source code right there in the source code box. Make sure that my language is C#. You want to put a check in the box that reads line numbers. And then in order to get my source code converted into the HTML code, now we want to click on the highlight button. And then we want to copy the HTML box. We don't want to copy the preview down here. So I go up into the HTML box and click, and it selects everything for me. I'll just do Control C to copy that. Then we'll just go back in here. Let's go to student view. Go ahead and go to our home page. Actually, I guess we could have just gone to assignments here. And then you're going to submit the midterm assignment. So that's when we click on. Get the big red button up here, submit assignments. And now the key is once you've clicked on submit assignment, remember you still need to go into the HTML editor. You don't want to paste the HTML code in here. That's what it's going to look like. That's what's going to show on my screen. I'm going to give you a 0 for that. So don't do that. You got to go to HTML mode first. Then you can go ahead and paste that code in there. Click submit. And then when you go back, if you review the submission details, it should look like that. That's what I should see on my screen. Then I can very easily tell if everything's done there correctly or not. Any questions about that?
Nope.
Well, I assume that's a no from everybody else, and you're all prepared then to go ahead and complete your midterm assignment. Hopefully you were following along and you pretty much have it done and ready to go. So just make sure you get that submitted before 11:59 p.m. tonight. That's when it's due. Actually, oh, that's my submission. I was looking up here. It said April 21st at 9:54 a.m., but that's when I submitted it. But I don't know where you guys see it. I guess it's right in here. Yeah, so there it is, April 21st, 11:59 p.m. So that's pretty much everything I have for you today. When we get together again on Thursday, we'll be moving on to our next lesson, lesson 8, which is the control structures. So now we're going to start introducing you initially to repetition structures. So that's, I was showing you some of the looping today, the do while loop and the for loop. So that's in lesson 8. And then when we get into lesson 9, which is the continuation of our control structures, we'll introduce you to what are called decision structures, which are if statements and switch statements and things of that nature. And those are the kind of the nitty gritty. Those are structures that we use quite a bit, as you can see just from the examples that I was showing you here today. We're constantly using looping structures to repeat code when we're going through data structures that have multiple values in them, because that's the way we can target each value individually and perform the same operation on each value as we go through a collection of items. And then decision structures, as you saw too, that's how our code can make we can set up an expression in our code that evaluates whether something is true or false. And if it's true, then the code inside of the if statement will run, and if it's false, it'll skip and move on to elsewhere in the code, further down in the code. So that's what all's coming up here. Control structures, first lesson, repetition on Thursday, and then next week, Tuesday, we'll get into the decision structures, and then Thursday of next week, we'll introduce you to setting up your own custom methods. We'll talk about the difference again too between functions and methods. Those are just the terminology it changes whether you're using object-oriented language or procedural languages. And then we get to file I/O after that. That's a pretty cool one. That shows you how you can actually write a program that will allow you to take user input and save it to a file on the hard drive, and then open a file from the hard drive and actually retrieve user typed input. And then we'll talk about exception handling, which is the way that we set up our code so that it doesn't crash if we have some sort of logic errors like divide by zero errors and whatnot in our code. We don't want the program to crash on our users. They probably won't use it anymore. And so if something like that occurs, you can actually catch those things. You can handle those things. You can say, oh, if this happens, then go ahead and do this. Don't crash the program. Just kind of reset the program and continue on. So all that's what's coming up. Your final assignment, if I remember correctly, is kind of combining then all of these items at the end here. You're going to be using the modular programming. You're going to be opening and reading files and writing the files, and you'll have to wrap everything in an exception handling statement so that if there is an error that occurs, your program won't crash. That's all leading up then to the final assignment. We will have a couple other assignments in the midterm, or in the meantime, I guess I should say. So assignment 3, that's where you're going to actually create a custom method Assignment 4, you're going to combine the file IO with the exception handling, because that's one of the biggest problems we have with file IO. If your program expects a file to be there and it's not there, then your program would crash. And so that's what we'll do, is we'll wrap our file IO request in an exception handler so that if the file doesn't exist, our program won't crash. So that's in assignment 4, and then you'll take the knowledge you learned from those 2 assignments, and that'll hopefully make it so you can complete your final assignment without any trouble. So that's kind of where we're at and where we're headed. Any questions from anybody?
No, thank you.
Nope.
Then thanks for joining me this morning. I'll see you again on Thursday.
Thank you.
Thank you and goodbye all.